All right, let's start by squaring both sides. The right side of this equation is a little bit easier. It's just x plus 22. The left side, okay, again, we square the first term and we square the last term. But you get double the product of the two terms together. 2 times x is 2x, and if we double it, we get 4x. I'm now going to subtract x from both sides, as well as 22. I've changed this to the equation x squared plus 3x minus 18 is equal to 0. I think this factors. Okay, we get x and an x, a positive and a negative, and it would be a positive 6 and a negative 3. The product is negative 18, and they add to positive 3. Perfect. But here the solutions are, looking at this one, x is equal to negative 6, and x is equal to positive 3. We have to check, though, to make sure. Are these both solutions, or are they extraneous solutions? I'll start with negative 6. I don't have a good feeling about this one. If we go back to the original equation, which is x plus 2 is equal to the square root of x plus 22, I already know it's not going to work. On the left, you get a negative number. But just to complete this, to write the whole thing out, is this true? The left side is negative 4. The right side, 22 plus a negative 6 is 16. This is a false statement because the left is negative 4 and the right is positive 4. What this means is that x equals negative 6 is an extraneous solution. It does not work. But we also have to check 3. I think this one should be okay. If I put 3 into the left side and the right side, this looks good. Is this a true statement? Well, 5 on the left, is that equal to the square root of 25 on the right? And it is. 5 is equal to 5. That means x equals 3 is, in fact, the only solution to this equation. And I didn't write this down, but this was part A. Let's look at part B. Solve 2x squared plus 9x is equal to 5. I want to use the quadratic formula for this, which gives us the solution to any quadratic equation, provided it is exactly of the form ax squared plus bx plus c is 0. So one side must be 0, and that is not the case in this equation. So I first need to subtract 5 from both sides, and really I'm working with the equation 2x squared plus 9x minus 5 is 0. Here, a is 2, b is 9, and c is negative 5. Using now the quadratic formula, my solutions are negative 9 plus or minus the square root, 9 squared minus 4 times 2 times negative 5, all over 2 times 2. If I simplify this, okay, in my calculator, 9 squared minus 4 times 2 times, gotta be careful with this extra negative 5, I get the square root of 121, which I think is going to work out to be a perfect square. That is, x is equal to negative 9, that's 11. The square root of 121 is 11, so this. Here are my two solutions. Negative 9 plus 11 over 4, and negative 9 minus 11 over 4. All right, so the top one there is going to be 2/4, positive 2/4, or that reduces to, positive 1/2 versus negative 20 over 4, which is equal to negative 5. These are the two solutions to this quadratic equation, 1/2 and negative 5. To solve this equation, I'm going to remove the greatest common factor. I'm actually going to take a negative out with it. And it looks like I can remove a 2 and an x to the 9th. So I'm taking out the negative, 2, and x to the 9th. And then I write down what is left over after I do this. I get a positive 4x and then plus 1. I like to check by multiplying this back in. Negative 2 times 4 is negative 8. X to the 9th times x to the 1st, the 1 and the 9, add to 10. And if I multiply this to a positive 1, I do get a negative, a 2, and an x to the 9th. The last thing to do is to set both factors equal to 0. And when I do that, the left one, again, really simple. It's just going to be x is equal to 0. The one on the right, I would have to subtract 1 from both sides. I get 4x is equal to negative 1, and after I divide both sides by 4, I have my second solution. X is equal to negative 1/4. These are both solutions to the original equation. Let's check out the last part, part D. We have negative 1/4 plus 5 over 8x. Where is that equal to 3 over 2x? To solve this, I want to change it from a rational equation to hopefully a linear one by multiplying both sides by the least common denominator, which, if I have a 2, a 4, and an 8, I have to have 8, as well as x. This is the least common denominator. I'm going to multiply it to every single term within this equation. That is, you have 8x over 1. That is multiplied to negative 1 over 4. To that I add, again, I'm doing 8x over 1 multiplied to 5 over 8x. And this is equal to multiplying the right side by 8x. It's 8x over 1 times 3 over 2x. I put an extra pair of parentheses here because of this negative value. I could have just put this negative right out front, left off the parentheses. I just chose to write it this way. Because this number is negative, I could really just move this over here and cancel my factors like we did in the previous questions. But I'm just going to note that 4 goes into 8 twice. I've canceled everything I can with this very first fraction, and I get negative 2 and x left over. In the second one, I can cancel the 8's and the x's, and all that's left over is the 5. On the right side of my equation, I can cancel 4 into the 8 and the x's as well, and I'm left with 4 times 3, which is 12. To solve this equation, it's now linear. I'll subtract 5 from both sides. I get negative 2x is equal to 7, and after dividing both sides by negative 2, I get my final answer. X is equal to negative 7/2. To multiply these two rational expressions together, I'm going to start by factoring each term. In the numerator on the leftmost fraction, I can factor out an x squared, and what's left over is x plus 6. That's nice. I actually completely factored this. There's nothing left to do. Now, in the denominator, we have a difference of 2 squareds. Like, there's no greatest common factor that can be removed. So the best we could do is, put an x and an x. It's got to be a positive and a negative, and 6 will be the correct choice. 6 times negative 6 is negative 36, and the sum is 0. If I look at the second fraction, in the numerator, I have to have an x and an x, a positive and a negative. I want a positive 5 and a negative 6. The sum is a negative 1, yet the product is negative 30. In the denominator, there's a greatest common factor of x, and if I remove it, I'm left with x plus 1. So everything's completely factored now. There's no extra step to add in, only to cancel all the common factors. I see this x plus 6 cancels with that x plus 6. I have an x minus 6 that cancels with that x minus 6. I can't cancel the x plus 5 or the x plus 1. However, there's this x to the first that can get rid of one of those, and I'm left with an x to the first in the numerator. Altogether, in the numerator, there's an x to the first, and there's an x plus 5. In the denominator, there is an x plus 1, and that is my final answer. All right, let's factor this expression. I'm first going to remove a greatest common factor, and it looks like I can take 5 as well as an x cubed out of every single term. And when I do, what is left over is 5x squared plus 36x plus 7. So to solve this question, I'm done with the 5x cubed, but maybe I could break up the part with the x squared into two pieces. You could take a guess and check approach, but I think off to the side, I'm going to deal with this separately and plug my answer back in when I'm done. And I'm going to use that trick where, okay, I'm going to take the product of the first and last numbers, which is 35, and I want to look for factors of 35 that add to 36. I think this is going to be pretty easy. 1 and 35 add to 36. I use these two numbers to break apart 36 as follows. I get 5x squared plus 1x, which I'll just put x, then plus 35x plus 7. I'm now going to remove the greatest common factor from the first and last two terms and go from there. From the first two terms, I can take out an x, and I'm left with 5x plus 1. And from the last two terms, I can take out a 7, and I'm also left with 5x plus 1. So this trick works because it will make this factor and this one the same, meaning I can factor out 5x plus 1, and it leaves me with an x and a 7 left over. I'm now going to take this information and plug it back into the original problem. I'll put 5x plus 1 here, I'll put x plus 7 here, and this is my final answer. To solve this system of equations, I think I'm going to use the addition method again. And I think since there's a negative and positive in both of the x terms, I'm going to try to cancel the x's. I'll do this by taking the top equation and I'm going to multiply it by 4. I'll take the bottom equation and multiply by 3. The top equation, if I multiply by 4, gives me negative 12x plus 8y is equal to 40. The second equation, if I multiply by 3, gives me 12x plus 15y is equal to 6. Now that I have a 12 and a negative 12, if I add these two equations together, the x's go away, but the y values that we end up with are 23y is equal to 46. I think this will work out nice. If I divide both sides by 23, I get that y is equal to 2. The only thing that I do not know is what is the value for x, and I can use any equation that has both an x and a y to solve for it. I'm going to use the very first equation. I'm going to take negative 3x plus 2y is equal to 10. Take this value for y, plug it here, solve for x. We get negative 3x plus 2 times 2 is equal to 10. Negative 3x plus 4 is 10. Subtracting 4 from both sides gives me negative 3x is equal to 6. If I divide both sides by negative 3, I get that x is equal to negative 2. This is my solution. X is negative 2, and y is equal to positive 2 will make both equations true at the same time. For part A, I'd like to find the slope of the line between these 2 points. I'll use my formula for slope that I've listed above. I need to make a choice. I think I'll call x1, y1 this first set of points and x2, y2 the second one. So my slope m is equal to y2 minus y1. That's 31 minus 15, divided by x2 minus x1, which is 12 minus 4. Okay, so the top is going to be 16, and the bottom is 8, which means I have a slope of positive 2. That is all part A was asking for. And part B is essentially asking for the equation of the line, and from that, can we identify what the y-intercept is equal to? Well, since we just figured out that the slope is 2, why not go ahead and plug that into our equation? This means the only thing that we don't know is b. I can use any point that I would like to solve for b, so my choice is going to be to use 4, 15. Doesn't really matter, I guess the values are smaller, why not use that one? In place of x I'll put 4, in place of y I'll put 15. So I get 15 is equal to 2 times 4 plus b, or 15 is equal to 8 plus b. The only thing I have to do is subtract 8 from both sides, and I get 7 is equal to b. Great. This is in fact the y-intercept, 0, 7. But ultimately, the equation of the line is 2x plus 7. I can now use this in part C to figure out, well, what is the x-intercept? The place where this graph crosses the x-axis. I take my equation and set it equal to 0. I'll subtract 7 from both sides, and then divide both sides by 2. And we can leave our answer as negative 7/2. And perhaps I'll put this in as a point, and note that this is the x-intercept. And that is it for this problem. All right, I'm going to divide these two polynomials. Again, I'm putting the x minus 4 on the outside of this division symbol. I want to start by canceling this 5x cubed. That means I have to multiply this x by a 5 and an x squared. I'm going to place that above the x squareds to keep everything nice and ordered. But that is 5x squared. I multiply it to x, and it puts 5x cubed right here. I also have to multiply this to the negative 4, which gives me negative 20x squared. I'm going to copy both of these things down. 5x cubed minus 20x squared. I am subtracting these two things, and when I do, this is good. 5x cubed minus 5x cubed is 0. I won't write it. Here, I have to be careful that I'm subtracting a negative. This becomes addition. This is negative 13x squared plus 20x squared. That is a total of 7x squared. And then I bring down the next term, which is negative 29x. I now want a 7x squared right here, which means I have to multiply this thing by a 7 and an x, which I'll put above my x's. 7x times x is 7x squared, but 7x times a negative 4 is a negative 28x. I need both of these things, because when I subtract them, I get that the 7x squareds cancel, but this minus a minus becomes a positive. Negative 29x plus a 28x is a negative x, and then I bring down the 4. To get a negative x, I have to multiply by negative 1. I get a negative x, but I also get a positive 4. I mean, this is perfect. This means my remainder is going to be 0. When I subtract these two things, I have 0 left over. That's my remainder, and the answer is 5x squared plus 7x minus 1.